Welcome to Across the Globe. Today we will learn about data visualization with Matplotlib. Data visualization involves visually representing data to identify patterns and relationships. Matplotlib, a widely used Python library, enables users to create diverse and high-quality visualizations like line graphs, scatter plots, and histograms. For example, businesses can use Matplotlib to display sales trends over time or compare performance metrics across different regions. Through Matplotlib, data analysts can efficiently communicate insights and make data-driven decisions. To create a simple line plot in Matplotlib, you can use the plt.plot function. First, import Matplotlib's pyplot module as plt. Next, define your x values using np.linspace from NumPy, for instance, generating values from 0 to 2pi. Then, calculate the corresponding y values, like the sine values of x. Finally, call plt.plot xy to create the line plot and pl.show to display it. This example shows how to plot a sine wave using Matplotlib. Matplotlib offers customization options for plots. Parameters like color, line style, marker, and labels can be employed for this purpose. For instance, in a line plot, one can use different colors and markers to enhance visualization. By specifying values like color equal red, line style equals mass, and marker equals O in the plot function, the plot's appearance can be customized. Additional elements like axis labels and a title can be added for clearer representation. This flexibility allows for fine-tuning plots to better convey data insights effectively. Matplotlib offers diverse plot types like bar plots, scatter plots, histograms, and pie charts. It enables the creation of visually appealing data representations. For instance, a bar plot in Matplotlib can be generated by defining categorical values for x and their corresponding numerical values for y, then utilizing plt.bar to create the plot. Customizations such as labeling the x-axis with plt.x label, the y-axis with plt.y label, and setting a title with plt.title enhance the plot's clarity. Finally, the plot is displayed with plt.show. This allows data analysts to effectively visualize categorical data, like sales figures of different products or survey responses across various demographics, aiding in data interpretation and making informed decisions. Data visualization with Matplotlib is like a chef presenting a beautifully plated dish to showcase the ingredients and flavors in a visually appealing way. Just like how a chef carefully arranges different elements on a plate to create an aesthetically pleasing dish, Matplotlib allows users to customize and arrange data points in a visually appealing manner on a graph. By using Matplotlib, users can translate raw data into a visually appealing representation, just like how a chef transforms raw ingredients into a delicious dish. Matplotlib can be compared to a skilled artist who can paint a picture with data, using colors, shapes, and patterns to convey information effectively. Through Matplotlib, users can create eye-catching visualizations that make it easier to interpret and understand complex data, similar to how a well-plated dish can enhance the dining experience. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The Python code snippet leverages Matplotlib to visualize data in the form of a sine wave. To initiate the visualization, the NumPy library is imported alongside Matplotlib, a versatile plotting library for Python. By generating data points corresponding to the sine wave using np.linspace and np.sin, a dataset is prepared for plotting. The plt.subplots call creates a figure, the canvas, and an axis, a subplot, to render the sine wave. Drawing a line plot of the sine wave is achieved through ax.plot, where customization options like color, line style, line width, and label are defined. The x-axis and y-axis are labeled using ax.setXlabel and ax.setYlabel, with an overarching title set via ax.scortTitle. A legend is included in the visualization employing ax.legend to assist in understanding different components of the plot. Ultimately, the visualization is presented with plt.show. This code exemplifies how readily and effectively Matplotlib can transform data into easily digestible visualizations. For instance, in real-world scenarios, a financial analyst could use similar line plots to portray stock price movements over time accurately to stakeholders, enabling informed decision-making. In the realm of industrial applications, data visualization using Matplotlib plays a crucial role in various sectors. One such example is in financial markets. Investment firms and traders utilize data visualization to analyze stock prices, trends, and market movements. By creating visually appealing plots and charts using Matplotlib, professionals can make informed decisions based on historical data and market analysis. Another real-world application of data visualization with Matplotlib can be seen in the field of healthcare. Medical professionals and researchers use visualization techniques to analyze patient data, study disease patterns, and interpret medical imaging results. Matplotlib allows them to create informative visuals, such as histograms, scatter plots, and heat maps to better understand health outcomes and treatment effectiveness. Across the globe, industries rely on data visualization with Matplotlib to gain insights, make data-driven decisions, and communicate complex information effectively. By harnessing the power of visual representation, professionals can uncover trends, patterns, and correlations within their datasets, leading to improved outcomes and performance. Keep learning, stay curious, and I'll catch you in the next video.